Laplace transforms with initial values. Look at this. I have y to the fourth minus y to the third derivative. That y to the fourth is the fourth derivative of y. And then plus 6 times the second derivative of y minus 4 times the first derivative of y plus y is nothing. My initial conditions y naught is nothing. Y prime naught is 1 and, whoa, there it is. Y prime prime naught is 1 and y prime 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 naught is 1. Alright, so we Laplaciate. It's linear. So the sum of Laplace is the sum of Laplaces, and I can pass those constants out. And that's what I did there. So now, how does the Laplace of the fourth derivative of y shape out? That guy right there, that's s to the fourth times the Laplace of y minus s to the third times y naught minus s squared y prime naught minus s y prime prime naught minus y prime 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 naught. Alright, let's expand out that next part. That's minus 4 times the s to the third, the Laplace of y, minus s squared y naught, minus s y prime naught, minus y prime prime naught. It's not the magic formula in your book, although you treat it as such. There's a nice proof. You can look through it. Now, that next piece, that's 6 times s squared, the Laplace of y, minus s y naught minus y naught. Y prime naught. Okay, and that other piece there, I expand that out in the same manner. Similarly, I bring down that Laplace of y. Now what? I use my initial values, the initial conditions. Now I'm going to expand out each one of those so that it makes nice, pretty print. When I plug these guys in, that's still s to the fourth Laplace of y minus s to the third. Y naught is 0, so that's 0. Minus s squared, 1, because y naught of 0 is 1. Minus s y prime prime naught, which is 1, minus y prime 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 naught, 1. Alright, so then that next bit, that's 4s to the third, the Laplace of y, and then, that guy right there, boom, you're nothing. And that should have been nothing. Bam, I think I get that again in a minute. But then I distribute in that 4, or minus 4, that's why it's plus 4s, and then plus 4. We keep on keeping on. That's a 6s squared times the Laplace of y, and then that's my, look at that. That should have been gone too. And then that's 6 times 1, which is 6. I keep on going on. 6. So then, that's a minus 4s times the Laplace of y minus, y naught is 0. Okay, I keep on. And then I add that Laplace of y. Now what do I want to do? I want to gather, collect, and combine. Because I'm solving for the Laplace of y now. So, I have s to the fourth minus 4s to the third plus 6s squared minus 4s plus 1 times the Laplace. That's all of these guys. Right there. Bam. Because I factored out that Laplace. And then what was left over? These guys, a minus s squared plus 3 s's, and then my guess is that it's minus 3. Then what do we do? We're solving for the Laplace, so I have that right-hand side. When I add that s squared to both sides, subtract off that 3s, and add that 3, and I divide it all by that stuff underneath the Laplace. So now you're lost, because you're like, what do I do? Now you look at the bottom there, and you see 1, 4, 6, 4, 1. That's binomial expansion. And that's how it factors. So I have that numerator over s minus 1 to the fourth. How are you ever going to see that? Oh, you got skills. Do work, son. We gotta do partial fraction. That's a repeated linear root, so that's a over s minus 1 plus b over s minus 1 squared plus c over s minus 1 to the third plus d over s minus 1 to the fourth. Now what? We add that fraction over there on the right-hand side, multiplying each numerator by what its denominator is missing from that common denominator, and then putting it all over the common denominator. I'm going to go ahead and I'm going to multiply those out. That's binomial expansion again, and binomial expansion again, and then that's that c times that s minus 1 plus d, and that's all over that common denominator. Now what? Now I need to line up the coefficients. Whoa there. So I have as to the third, alright, because that's my only to the third term. And then I have a minus 3a, that comes from here and here. And then I add that to a b, because that comes from here, alright, and then that's all my s's squared. Then what? Then I gather my s's. I see I have an 3as and a minus 2bs and a cs. Okay, that's how I gathered my s's. And then I get my constants. There's a minus a and a plus b and a minus c and a d. Okay, and then that's how I got my constants. Because now I need to equate my constants. With what? With my original polynomial, or at least the polynomial on top, since I did not have a leading term, I did not have an s to the third, a is equal to 0. Further, my minus 3a plus b is equal to 1, and then my 3a minus 2b plus c is equal to a minus 3, and then my minus a plus b minus c plus d is 3. We finish. I see that my a is equal to 0. I'm rewriting this stuff, okay? Okay. So now that I got it all rewrote, I know a is 0. So that says that my b is 1. After that, I take my b and I stick it there, and I see my c is minus 1. And then after I get my c is minus 1 and my b is 1, I stick them both there, and I find my d is 1. So now what? I have my Laplace. It has all been solved out, and not solved out, but algebra leads us to be that our Laplace is going to be our expansion. Now I'm going to plug in my a's, my b's, and my c's. Since my a is nothing, I'm not going to write it, but I'm going to put my b, my c, and my d appropriately. Now that I have that, I have to look at my table of Laplace transforms, and I see t to the n e to the at is equivalent in Laplacian to n factorial s minus a to the n plus 1. So I'm going to rewrite all of my partial fraction in the proper form. I see that's 1 factorial s minus 1 to the 1 plus 1 minus 1 over 2 factorial times 2 factorial. Notice what I had to do here. I had to put that 2 factorial down there to balance out that 2 factorial over there so that I can get that 1 right there. Similarly, I had to put that 3 factorial there and that 3 factorial there to balance out with that 1. Now that I have it written in the form, I can match my pieces up. So that's t to the 1, e to the 1t, minus 1 over 2, t to the 2, e to the 1t, plus, because 3 factorial is 6, that's 1 over 6, t to the third, e to the 1, and I'm done. Box and flower.